Hey guys, here with the homework review for Wednesday's homework, which was 8.5, day 2 of adding and subtracting rational expressions. So, again, just want to thank you guys for filling out this form. If you haven't used it yet, it's very helpful for me and hopefully you as well, and especially if you're struggling with the homework, just to give some feedback. So, these are the responses that we got. Um, Number one looks pretty good. Number two, I'm going to go over number two because there are a couple questions about the common denominator number two. Three is probably our best one. Four is pretty good as well. I think there was one question about four. Um, Five, not too bad. And then six. So I'm going to go over, I think, two and six and try to answer some questions in between there as well. All right, and then here are the questions I got. So let me flip over to the homework and let's get started. So one of the questions was specific questions about number two um, and how I got the LCD. So here's what I do is I look at each term and I look at the denominator of each term. Okay, so I know my LCD must have a 2x minus 5, right? That take care of that. Now, in order to figure out the second one, I need to factor this. Well, it turns out this is a difference of squares. Okay, so what you do, and I know that because both 4 and x squared and 25 are perfect squares. So you take the square root of each, and you get 2x, and you get 5. So this actually factors to 2x plus 5 times 2x minus 5. Okay, and you can check that. You're right. You can multiply that out and distribute it and make sure you get the same thing. So I need a 2x plus 5 in my LCD. So I have a 2x plus 5. And then I need a 2x minus 5. Well, I already have a 2x minus 5. I don't need another one. Okay, and that's how I get my LCD. Okay, um, let's skip down to, um, I'll actually do 5 and 6 because there are a couple questions on both of those. So here we go on 5. First step is you need to find your LCD. In order to do that, you need to factor this. This bottom denominator becomes p minus 9 times p plus 3. So your LCD is going to be, well, you need that first denominator. And then the second denominator is just p plus 3. Well, you already have that, so you don't need it again. Okay, now I need to multiply in order to get both terms to have the same least common denominator. The first one already has it. The second one is missing p minus 9. So I'm going to multiply top and bottom by p minus 9. All right, so then the second step, first term stays the same. The bottom I'm going to write in the factored form now. The second term I'm going to distribute the 4 to the p and to the 9. And now I have the same common denominator. Okay, and now since I have the common denominator, I can go ahead and combine the numerator. Now, important thing, because this is subtraction, what you need to do right here is you need to make sure you distribute this negative. So my top will be p squared plus 2p minus 51 minus 4p plus 36. This right here is what we miss a ton. It's plus 36 because we're distributing that negative. All right, and then one common denominator now. Okay, let me combine like terms on top. I'm going to get p squared minus 2p minus 15. Okay, now I want to factor the top. And the reason we have to factor the top again is to see if there's any common factors between the top and the bottom. So the top is going to factor to p minus 5 times p plus 3. Denominator stays the same. We do have a common factor. We can cancel out. So that gives us our final answer of p minus 5 over p minus 9. Okay. And then let's do number 6. And I knew number 6 was going to be a little tricky because of the factoring. So, whatever factoring method you want to use, I'm going to do the box method over here. Okay, so I'm going to show this over here. So, A times C, 3 times 8 is 24, B is 14. So I need two numbers that multiply to 24 and add to 14. So common factors of 24, 1 and 24, 2 and 12, 3 and 8, 4 and 6. Okay, which one of those is the 14, 2 and 12? All right, so I'm going to draw my box. All right, and in the box method, first term stays the same, so 3a squared. Last term stays the same, plus 8. I split the middle term, which is 14a, into the two numbers I found up top. So 14a now becomes 2a and 12a. Okay, and now I'm going to take the GCF. So take the GCF across of each row and then down of each column. So here it's going to be a, here it's going to be plus 4. Going down, it's going to be 3a, because remember the GCF is both the number and the variable. And going down here, it's going to be plus 2. So what does that mean? That means that this first term denominator factors into a plus 4 times 3a plus 2. Okay, and we had to do that just to find the LCD. So now we know our LCD is going to be a plus 4 times 3a plus 2. So what are we missing from the first term? Nothing. What are we missing from the second term? A plus 4. So we're going to multiply top and bottom by a plus 4. Okay, now let me rewrite this down here. First term stays the same because it already had a denominator that was the LCD. Second term, I'm going to distribute the 4 to the 7a, to the a plus 4. I get 7a plus 28 over the LCD. All right, now I have common denominator I can combine on top. So this becomes 8a minus 18 plus 7a plus 28. Go ahead and combine them and get 15a plus 10. Okay, here's a step where we need to factor the top again if we can, and we can. And the reason we do that is to see if there's any common factors. We can take out a 5 from the top. And you see it, that gives a common factor of 3a plus 2. Cancel that out. We're left with 5 over a plus 4. And that is our final answer. So the tricky part on that one was really the factoring. Okay, if you're able to factor that first denominator, you're able to determine the LCD and go from there. Okay, questions. How does the last one work? Just went over that. I know most of it could use some extra guidance, especially in the last problem. This question, could you use the quadratic formula on number 6 to find the factor? So this is asking, instead of doing the box method that I did right there, can you use the quadratic? The answer is yes, but you have to turn your answers into factors. Okay, because remember what the quadratic formula does for you is that it solves for the variable. So it would give you it gives you the 0, gives you the x-intercept. So you would have to, think of it as a solution. You'd have to turn it into factors, which means you make it the opposite. Okay, so I'm going to say yes, have to turn solutions into factors. So for example, if you use the quadratic formula on that one, you should get a is equal to -4. Well, if that's your solution, the factor would be a plus 4. So you just have to remember to turn it into the opposite. Okay. Number 2, y both 2x and 2 minus. So I went over that. Number 5 I went over. Hopefully that was helpful. The next one, number 6 was confusing. Got that. Next one was also on number 6. And finally, number 4. Okay, I didn't go over number 4. It says, could you cancel out the k squares completely, or can you only cancel out k from both to get k plus 3 and k minus 1 instead? So the answer is you can't cancel out the k's because it's addition. So depending how you did number 4, this may or may not make sense. Not multiplication. And whoever asked this question, if you need more clarification, send me a quick note so I can see your work. But here's an example. If you have k squared minus 3 over k squared plus 1, you can't cancel out those k's because this is, right, subtraction and that's addition. You can't do anything with those k's, okay? So I'm going to say here, nothing to cancel. However, if you had this, here you could cancel out the k squares because it's multiplication, right? If you put a negative right there. So it can cancel because operation is multiplication. Because in that case, it's a common factor. With addition, you don't have the common factors there, right? But with multiplication, you have common factors, and that's when you can cancel out. Okay, hopefully that helped. All right, guys, that's all we have for today. Continue to fill these out for me. They are helpful, and hopefully the review I give back to you is helpful as well. Thanks.